So I'm going to show you the functionality of the website, PWA, Personal Wardrobe Assistant, wardrobes redefined. Again, this page is reactive. So as you can see, I can change the size. It does not matter. It's going to resize. Hamburger menu. So really quickly, obviously sign up. I'm going to create a new account. Before I do that, I'm going to show you the service. So these are the articles. Obviously on the user page, you're going to have multiple wardrobes. Each wardrobe having their own amount of articles. Each article having a picture, description, RFID, times used, and status. About us, this is myself, O'Neill, Efren, and Max. There is validation on the sign up page. You can see right here, nothing's gonna happen. I need password, email, and username. Let's go ahead and name Katara3, 123 at gmail.com. Sign up, 123456, 123456. Boom, sign up. Welcome Katara3. And I go ahead and add all the wardrobes we want. It doesn't really matter. I'm gonna go ahead and delete some of them. So normally you will add articles when you check an item in. If it's not in the database, it will get added to the database, but we're simulating that right now. We're just gonna add those pants, a random RFID tag because we don't know them. To keep it simple, let's just do 3. I don't know, I'm guessing those were gray. Type pants, description, test pants, testy pants. So they go ahead and show up. Go add another wardrobe, select that wardrobe that is going to show up because our wardrobe is empty, and go back to this one. When we do the presentation, the part of the presentation where we're checking in and checking out items, we're going to check how, again, you can update them and how they're added to the database, even if they're not in the actual database. So we're going to go ahead and log out. Sign back up. We can log into a different account. So let's do this one. I'm pretty sure this is an account. All right, see how we're unable to log in? That account doesn't exist. So if we go to one of the many ones I have here, again, that one doesn't exist. Let's try that one. There we go. That one does exist. So now we are here in testing 1, 2, 3, 4, 5. Again, add as many articles as you want.
Hello, so for the power supply, we had 2 batteries for this project. One being a lithium-ion battery about 3.7 volts with a current of 500 milliamps per hour. And this is solely responsible for powering the microcontroller, which is the brains of the operation, and it is very vital that this thing works. Second, we have our major power supply, which is 8 AA batteries connected in series with another, and this produces an output of approximately 12 volts, and this is then wired through the back here directly to the PCB. We also added a on and off switch that allows the users to turn on and off the project, obviously. So the regulation circuit itself is quite simple. It consists of only 4 components. A 1N4001 diode for overvoltage protection, 2 capacitors, a 10 microfarad capacitor and a 1000 microfarad capacitor, and these are here mainly because even though it's a DC circuit, they're there to create stability and help with the transient response. They also smooth out the signal, which can boost the antenna in the end. And finally, we have a L7805 voltage regulator, which converts the 12 volts from the battery to 5 volts DC, which is used to power the RFID reader and the LCD screen. And from the reader itself, it powers the antenna.
Okay, so I'm gonna talk about the RFID reader and the antenna. Let's start with the RFID reader. The RFID reader that we choose for our project is the ID3LA. This RFID reader is based on a 125 kilohertz, which is low frequency RFID tags. This RFID reader doesn't have an antenna integrated, that's why we create this antenna here. So we soldered this part to the PCB board. As we can see, the pins that we're using are the ground, VCC, the antenna pins, and also the D0, which is gonna communicate with the microcontroller. Okay, and then as for the antenna, what we have here, we have some copper coil around it. The copper coil is the 30 AWG, which stands for American Wire Gauge. So that's the thickness of it. For this one, we did around 120 turns based on our calculations, and we're able to scan between 5 to 10 centimeters, which is the desired distance that we want for the user. If we surpass or we have less than that, the user maybe you're gonna have some struggle with it. So let's try to test it. Just make sure it's between that range. So we got around 8 centimeters, so that's perfect for our project.
All right, so for this design, we went with the Adafruit Feather Huzzah for our microcontroller. And we used this module mainly to test, and we had to integrate this module into our final design for our first iteration. We actually have a stretch goal on our second iteration for this design, and we'll be using a standalone Wi-Fi module. But for demonstration purposes, we're using our Adafruit Feather Huzzah. The Adafruit Feather Huzzah is integrated with the ESP8266 Wi-Fi module that allows our device to communicate with the internet through post notifications or through post requests. The microcontroller communicates with the RFID reader through a serial bus, and it takes those bytes off of the serial bus once a tag is scanned. The microcontroller is programmed using the Arduino IDE, which made things a lot more simpler for us as the Arduino IDE is able to use C programming language, which we all understand. The microcontroller is connected through the PCB to the active buzzer, and we decided to go with an active buzzer because all we really need to do is send a signal to it, and it'll beep, and that's perfect for our application. And the microcontroller is also connected through the PCB to the LCD screen, which sends it prompts as the user scans items or either turns on and turns off the device.
Hello everyone, we're Group 17 for Senior Design 2, and this is our final demonstration. Here we have Juan, who is currently remotely streaming his stream. Say hi, Juan.
Oh, I'm here. You see my mouse?
Yes, we can see that. And now we will be demonstrating scanning in and out items of the wardrobe. O'Neill?
Item 1.
Item scanned.
Good to go. I received that one.
Refresh it.
Yeah.
Item 1 done. Put it in the closet, please.
I want to go ahead and update the article now. This file. Delete. This is a pattern shirt. Description. First item. Type. This is a shirt. Submit. For it to render. There's the first shirt.
Perfect. Item 2
The next one.
is a white shirt. Please scan item. Item is scanned.
I have received it. Go ahead and select the wardrobe again.
Okay.
Go ahead and update the article. And I
Welcome to
believe this was the
PWA.
white shirt.
You can scan the next item, O'Neill.
Description. Next,
RFID tag. Is it the shirt pocket? It's a different RFID tag.
the tag is also a shirt. Make notes how the shirt and articles are updating.
Final shirt.
You know,
Final shirt is ready to be
Let me know.
scanned. Yes.
let me know when you guys send the third item.
Third item has been scanned. Waiting on your end.
Item. Select. There we go. We gotta update this item. This item was the burgundy shirt. Sorry. Let's say red shirt for simplicity.
You just put.
This is a shirt. Let it render out. Good to go.
Fourth item
Please.
is a pair of blue pants with the RFID tag sticking out of the pants. Please scan item. Item scanned. There.
Yeah, here we go. Item here. Let me go ahead and update. I believe this wore the J pants. Just gotta look for them. I believe it was
Those.
this one right here. Open. Description. I might say blue pants for simplicity. Obviously, these are pants. Submit, let her render. There we go.
Final item being scanned in, a pair of gray pants with another different RFID tag. Please scan an item. Item has been scanned. Put back in.
And an update one. These are going to be pants. I believe these are the ones that we scanned. Description, other pants. And obviously, totals have been updated. And just to show you, I could select a different wardrobe. Nothing's going to be now.
We will now be demonstrating taking clothes out of the RFID out of the PWA. We're grabbing these gray pair of pants, taking the RFID tag, is ready to be scanned. Item has been scanned.
Perfect.
And has been taken out of the system.